8th grade, test 5.5. So I had to squeeze in a test in between 5 and 6 just to slow things down a little bit, get you guys all caught up. So 5.5, test 5.5. It says the Rams are on the 10-yard line. They got the ball. It says that they gained 7. On the second down, they lost 10. And on the third down, they gained 2. So there's two possibilities here. So either they're on their own 10, that means on this side where they're counting up, going this way. If that were the case, if they gained 7, they went this way, now they're up to 17. And lost 10, they'd count back down to 7, and then gain 2 more, they'd be on the 9-yard line. That's one option. The other option is this. They're over here on the opposing team's 10-yard line. And in that case, if they gained 7, they're counting down now, so you'd subtract 7 to get down to 3. And if they lost 10, they're going backwards, but they're counting back up, so that'd be at the 13. And then gaining 2 would be counting down again, going in the right direction, and be at the 11. So the only two options are they're either on the 11-yard line or the 9-yard line, and the test only gave you one of those options, so you picked the one they gave you, the 9-yard line. So problem number 2, we had to simplify this expression. And to simplify this expression, we're going to do multiplication first. So we pretend there are no decimals, right? It's just like doing 201 times 87. Okay, and there's the work there. Pause the video, do it yourself, and check with mine. Now we have to add the decimals back in. There's 1, 2, 3, so you add 3 decimals, and then we use Mr. Dude to decide our sign, right? If I'm multiplying positive times negative, I draw Mr. Dude's face, and I say positive times negative. Negative is, uncover it, a negative sign. So these two together equal negative 17 and 487 thousandths. So now I copy this part. I put 10 minus, and then that part I simplified. So now I'm subtracting. I do the rule for subtraction, line my decimals up, and my answer is 27 and 487 thousandths. Problem number 3, we had to simplify this expression, and fortunately they already did the factor trees for us for this one. So it's like multiplying fractions. Break them down, cross out your 1s. 5 over 5 is 1, 7 over 7 is 1, 7 over 7 is 1, and whatever's left to multiply will automatically be a reduced fraction. For number 4, we go ahead and do the rule for subtraction. Everywhere there's subtraction, which means I draw 2 sticks, right? So I go add the opposite, that becomes plus positive, and minus 6 means add the opposite is the same as plus negative. And the reason we do that, make all subtraction into addition, is so we can use teams, right? This is on the positive team, this is on the positive team, this is on the negative team. I have 15 on the positive team, 6 on the negative team. Opposite teams in the end means subtract, and I ask myself who has more. Positives have more, so positive 9 is the answer. Problem 5 says we have negative 1/6 times 4/9. Multiplying fractions just means factor trees. So I put the negative up top, right? Negative 1 times 1 is the same as negative 1. We always just pull out the negative 1, right? 6 is 2 times 3, 9 is 3 times 3, and 4 is 2 times 2. So we factor trees, cross out our 1s. So I got a 2 on top, 2 on the bottom. Everything left that I multiply will automatically be a reduced fraction. And when I have a negative on top or bottom, and I'm finished, I put it out to the side. 6 says negative 4/5 divided by 2/3. So in order to make this into a multiplication problem, I have to multiply by the reciprocal, flip it upside down. So I'm going to flip this one upside down. Never flip the first one, okay? And then I do my factor trees. Remember, I always put my negatives up top just so I know what to do with them. And 4 is 2 times 2. The other numbers are prime. Cross out our 1s. And negative 1 times 2 times 3 is negative 6. And on the bottom, 5 times, remember these are all 1s. 5 times 1 is just 5. And that's a reduced answer. That's an okay answer. But this time, I had you convert it just to make sure you're able to do both. So you would divide in and out. So negative 6/5 is the same as negative 1 and 1/5. Usually it'd be like this, but every now and then I'll make you convert it just to keep you up on that skill. So number 7, we had to add 2 fractions together. Remember, when you're adding fractions, you look at the bottom numbers, the denominator, numerator, denominators, and you want to see when they're the same, okay? So So the multiples of 4, 4 times 1 is 4, 4 times 2, 4 times 3, right? And the multiples of 9, 9 times 1, 9 times 2, 9 times 3. So looking at those denominators, the first time they're the same would be 36. So I want those bottom numbers to both say 36. So I look at 1/4 and I multiply it by 9 over 9. Because it's got to be to the top and the bottom, right? That way, when I rewrite 1/4 as 936, it's actually the same number. Because 9 over 9 equals 1, and 1 times a number stays the same. It just looks different, right? But it's the same number. That's why we got to do it to the top and the bottom, right? We talked about that a lot in class. So over here, it's got to be 4 over 4. Now that I have the same bottom number, means the same size pieces, right? We talked about that in class too. We add the numerators. Keep the same bottom number because that's how big the pieces are. I don't add those. And that's it. Make sure that it's reduced. Okay? And again, this one I had you guys convert it. So we divide in and out, 1 and 5/6. This is an okay answer too. This is okay. But if I don't give this to you, you got to convert it. All right. So number 8, we have to write as a fraction 4.1. Well, first thing we do is read it. 4.1 is 4 and 1/10. So then I write it as a fraction, 4 and 1/10. Reduce this fraction part, factor trees, cross out your 1s, but if there's a 1, of course, it's already simplified. Then I convert. I start at the bottom. I go 10 times 4 is 40, and then I add that 40 to the top number. 40 plus 1 is 41. Keep the same bottom number, keep the same denominator. 41 over 10 is the answer. Problem number 9, we had to find the 2 square roots. Well, since 3 times 3 is 9, and negative 3 times negative 3 is also 9, the 2 square roots are 3 and negative 3. You could also write this like this, plus and minus 3, can't you? So for number 10, they said a square room has a floor with 169 squares in it. That means the area is 169. So if you got a square, the way you find areas, you go base times height. Now, if it's a square, they're the same number, so whatever this is, we can call it x, right? And this has to be x too, because they got to be the same for a square. So that means x squared is 169. So we're figuring out, if I know what x squared is, and I need to know one side, I need to know an x. So what I do is I take the square root of both sides. And normally we have to take plus and minus whenever we draw that square root, because just like we said, you know, perfect squares can have 2 square roots, one positive, one negative, okay? But because this is a word problem, you can't have negative 13 tiles, so we have an extraneous solution. We leave the negative 13 out this time, even though we did the math right. But because it's a word problem, it wouldn't make any sense to include the negative this time. All right, so number 11 says, simplify this. The square root of 144 is just 12. The square root of 121 is 11, because 11 times 11 is 121. 12 times 12 is 144, so I add those two up and I get my answer. 12 says, which fraction, write the fraction 6/5 as a decimal. So we just divide in and out. This goes in, this goes out. Put your decimal here, right? Bring it up top. 5 goes into 6 one time. Subtract. 5 goes into 10 2 times. And 1 and 2/10 is the answer. So for 13 it says solve x squared equals x squared equals 121. Just like the last problem, we take the square root of both sides. Because solve means what's x, right? We know what x squared is. So if I want to make x squared become just an x, or solved, then I take the square root. That makes x squared become just x. But I got to do it to both sides when it's an equation. And this time I have to include the positive and negative answers. So another way to write this answer would be 11 comma negative 11. That's what this symbol plus minus 11 means. 14, we have x cubed equals 343. Now they're asking us, what do we multiply to itself 3 times? We're not dividing by 3. We're looking at numbers and saying, what's the cubed root of both sides? So when it's a 3, I put a little 3 in my little square root symbol, or my radical. That will make this x cubed become x. And what do I multiply 3 times to get 343? Well, we'll just kind of guess and check. 5 times 5 times 5 is 125. Too small. 7 times 7 times 7, 343. That works out. It just will take you 2 or 3 times and you'll get it. 15. They want us to, I want you to say what's the integers, what two integers rad 199 lies in between. So what I do is I look at the perfect squares and use those as radicands, right? So 199, I start to narrow it down. Remember how to narrow it down? We talked about this a lot in class. So 10 times 10 is 100. That's too small. That's smaller than 199. 20 times 20 is 400. That's too big. So I already know it's in between 10 and 20, right? These two numbers. And we memorized this in class. We memorized 15 times 15 is 225. That's a little too big, so I'm in the ballpark. So that's why I choose over here. I'll choose 14 because the 15 is a little too big. 14 is a little too small. 15 is a little too big. That means this. That means the square root of 199 is in between the perfect square, 196, 14 times 14, and 225, 15 times 15. So it's in between these two. And now I can simplify these perfect squares out. Square root of 196 is 14. Square root of 225 is 15, which means rad 199 is in between 14 and 15. It's 14 point something. 16, very similar idea, but we got to write this number to the nearest tenth. So again, we narrow it down. See, 400 is too big, 100 is too small, so it's in between 10 and 20. We memorize 15 squared is 225. So I know it's in between 15 and 20 now. Okay, so I just start guessing and checking, right? 17 times 17. If I multiply those two numbers, 17 times 17, I get 289. That's a little too small. 18 squared, 324. Still too small, but I almost hit it right on the head. So I know it has to be in I know it has to be in between 18 and 19, right? So the square root of 325 is in between the perfect squares 324 and 361. So it's in between 18 and 19. Now, in order to figure out is it 18.1, 18.2, 18.9, we just in class we learned this. We got to ask ourselves, is it closer to 18, 18.1, 2, or 3? It's kind of in the middle, 18.4, 5, or 6, or is it closer to this side, 18.7, 8, or 9? It's way closer to this. In fact, it's so close, it's only one away. We would say maybe 18.1, 18.2, unless this number here is really far away. In fact, this one is so far away, it's even closer to 18.0 than 18.1. But if you got in the ballpark, 0.1, 0.2, 0.3, anywhere even close, you're still going to get this right because none of the other answers on the multiple choice test will even be close. So, if you got 18.1, actual answer is 18.0 this time because it's closer to that. It's not exact, but it's closer to that. Okay? 17 says, state if the number rad 64 over 2 is rational or irrational. Well, if you can simplify that square root, that radicand, this square root, then it's rational. So that's a perfect square, so 4, so it has to be rational. Now, if this number inside, called a radicand, a number in a square root is called a radicand, if that is not a perfect square, then it's an irrational number. If it is a perfect square, it's rational. So, number 18, we have 12 over 6, and it looks like they want us to categorize that. Always simplify first. Since it simplifies down to 2, 2 is a natural or counting number, which means it has to be a whole number, which means it has to be an integer, rational, and real. And number 19. So we're going to estimate the irrational numbers for this. So rad 7, we talked about how to do that earlier. The two perfect squares that surround 7 are 4 and 9, right? 2 times 2 is 4, 3 times 3 is 9. Those are consecutive. One's too small, one's too big. That means rad 7 is in between the square roots of 2 and 3. So it's 2 point something, but 2 point what? Well, we ask ourselves, is it closer to 2 or closer to 3? And the answer is it's closer to 3, so that's usually 2.78 or 9. But look, it's actually kind of in the middle because these numbers are very close. It's not like this is a 2 and this is 13. This is a 2 and this is 3. That means it's really in the middle, just a little closer. So in the middle, but a little closer to that side is 2.7. Again, if you're in the ballpark, you're right. So rad 7 is about 2.6. Okay, and then they give us 1.7. Well, that's pretty simple. That's just in between 1 and 2. And then they give us rad 49. Rad 49 is a perfect square. That's exactly 7. Then they give us 1/2, which is just 0.5, and pi, which we know is about 3.14. So we got to place these numbers on a number line. So let me blow this up for you here so we can see what this looks like. Okay, so we said that rad 7, that was the first one they gave us, right? Rad 7 was about 2.6. So that goes about there, right? And then they said 1.7. 1.7 if 1.5 is in the middle of 1 and 2, 1.7 is just a little to the right. It doesn't have to be perfect. You just got to get close. Rad 49 is exactly 7, so put a dot on 7 and call it rad 49. 1/2, of course, is in between 0 and 1. And pi is a little, it's 3.14, so just a little past 3. If you're a little too far, it doesn't matter. Now, the thing is once you write it in order on a number line, you have to pick the answer that has these in order the same way you have it on here. So 1/2 is the smallest, then 1.7, then rad 7, then pi, then rad 49. Okay? So you can do this work on one of those number lines I give you on the test, and then write it in order from least to greatest, and then pick the A, B, C, or D that has it in the same order as you, and have those points in the right spot. Okay. And so now we have number 20, which we have to simplify. And we are multiplying powers with the same base, the same big X, right? So we copy the X and add all these exponents. There's a 2 there. If there's nothing there, there's a 1. So 2 plus 1 plus -1, we use teams. Add up our teams. We have a total of 3 positives and 1 negative. Opposite teams means subtract. Who has more? Positives have more, so it's X squared. All right, folks. Hope that helps.